Thank you. Good afternoon, everyone. I really appreciate that everyone are coming to my talk, especially this is a session before lunch. I know everyone are hungry, so let's get this talk done. And yeah, a brief introduction from me. I'm Iskandar Setiadi, and I actually comes from Indonesia, if you know. And I'm currently working in Henge in Japan for around 3 years and a half. And I've been to several PyCons, but mainly in Asia. So this is my first time in Europe, so I'm pretty excited about it. Yeah, this is about the map. If you know, the Tokyo is over there. My hometown is Jakarta is over there, and Italy like is far most over there, not in the map or not in this map. So yeah, my company is also a PyCon X Italy sponsor. You probably already saw our booth. It's near the restaurant near the lobby. And okay, let's get started about our talk. So yeah, more like a lot of people say like Python is slow, or let's migrate Python to this language, or Python is slow because it's interpreted language and stuff. But actually, there's a lot of big companies that trust Pythons. One of the showcase is Instagram. They have 400 million active users, and they migrated from Python 2 to Python 3 around like 2 years ago. There's also a lot of other companies such as like Quora, Reddit, Spotify, Dropbox, and many other big companies. So is it actually true Python is slow? And if it's true that Python is slow, why these companies are still using Python? So yeah, there's like some people say it's like this is the slowest things on earth. And some people say like Python is slow because it's in an interpreted language, which is, yeah, if you compare Python to like C++, of course, Python is slower than C++. And Python also has some problem because of the global interpreted lock, or famous, like known as GIL. And this is the number of requests per second. Like this is a micro benchmarks between like Tornado, IO, HTTP, Node.js, Go, and so on. But there's a good but here. In the previous benchmark, it shows like Tornado can serve like 2,000 requests per second. Node.js can serve like 50K requests per second. Golang can serve like also 50K requests per second. But the real question here, does your actual server can handle those number, right? Because if you, let's say our server can only handle like around 20 requests per second per Docker container. First, this number looks very small, but if you think about it, let's say one Docker container can serve 20 requests per second. In one instance, you have, let's say, 4 CPU cores, and you just spawn 4 Docker containers. And if you have 10 instances, you have 40 Docker containers, and in 1 hour, you already serve 2 million requests per hour, which is a lot. So the number probably looks very small here, but actually, we don't actually use like 2,000 requests per second for serving things. Our bottleneck is not in the micro benchmark itself. Usually, the framework doesn't really matter. You can use Tornado, or you can use AU HTTP or other languages, but usually your problem is not in the framework itself. So let's say this is from the user perspective. Let's say we are handling a single authentication request from a users, and the user thinks that each request takes around 400 milliseconds. And if we simplify it, like we try to make a breakdown of what happens in those 400 milliseconds. Let's say you need to retrieve, let's say, the user information. You need to retrieve the tenant information. You need to retrieve like the role-based policy for the user. And you have, let's say, 10 database calls. It already takes like 200 milliseconds if each call takes 20 milliseconds. So if you make a breakdown of from those 400 milliseconds, let's say like half of the time you actually spend it with your database call. Like the other, let's say 100 milliseconds is actually a latency problem. And sometimes you have a CPU bound things, for example, generating a cryptographic stuffs. And the 2,968 requests per second is actually like a very minuscule part of your problem. It's only, let's say, from this request, it's only like 0.3 milliseconds for handling a single Tornado request from the macro benchmark, which is shown here. So this is our problem. We know that we have a lot of problems with database stuffs. We also know we have a problem with IO bound latency. We cannot change it because it's basically speed. The limit is speed of light, right? So let's say your server is in Tokyo, but you currently live in Singapore. You cannot get your latency, let's say, lower than 50 milliseconds. So what do we actually need to solve this kinds of problem? The first problem is probably about usually is about your database queries. So in our company in the past, we have these kinds of problem in the past. Let's say the developer A, they create a module A to check something. The module A needs a user record. It also needs a domain record. Like some other developers, they develop a module B. It needs a user record and a device record, for example. But apparently, each module, they try to do its own database calls, which is very redundant because you actually can combine it together. So how we solve it is, so we found out that there are actually a lot of redundant database queries. For example, when you remove an old logic, but the database call still remains in your code, or sometimes some database items are retrieved twice or duplicated on a single request. So the idea is to use Python decorator to track those things. So if you don't know about decorator, this is a simple example of Python decorator. Let's say we have a database driver get item over there. We want to track like how many database calls that we do in each request that we serve. And for each request that we serve, we want to know like which database items that we actually get. So by tracking these kinds of things with decorators, you can track, let's say there's a get item operation over there. We retrieve, let's say, the user record, domain record. So this request takes 2 calls. And at the end, you get something like this. You get a nice data like shown. You can see like this request to pause takes like 370 milliseconds. It runs 12 number of queries, and it retrieves like domain 1 time, user 1 time, and so on. So with this thing, you can try to optimize your database query and remove the redundant calls for your database. The next one is probably like a lot of people already talk about this. It's about async IO. Because we are doing web development, async IO is a Python native asynchronous module. It's introduced in Python 3.4. But actually before that, like Tornado and several frameworks also try to implement the same thing with the asynchronous HTTP client and server. So if you have used Tornado before, you probably already know about how async IO works. And yeah, async IO is nice because it's an event-driven basically. So let's say if we run multiple processes of Python, the bottleneck will be the CPU level context switching, which is not nice. And let's say if we use the multi-threading in Python, actually we will have some problems with maintaining the thread itself. If you have like developed web application in Python with thread, you probably already know the problem with threading in Python. It's not that nice. And with async IO, the scheduling is done on the application level, so it's pretty nice. And yeah, the guy over here, my teammate, he's also giving a talk yesterday about how async itself works. So if you had come to his talk yesterday, you probably like get some insight about how async IO works. But here is a problem. When I was young, yes, I mean I was still young. I'm still young now, but I had like a problem like with understanding how async IO works. I thought like async and like await keyword actually will solve the problem, but actually it's not that simple. So here in the common pitfalls, let's say if you use AWS, you probably know Boto3. Boto3 is a AWS SDK for retrieving AWS, like calling AWS endpoints. So like initially, let's say you have a code like this. You have a code, let's say, to print a text message, and you have a long operation. Actually, the time slip is actually a Boto3 library in my code. But for simplicity, let's say it's a time.slip over there. And initially, when we run the code, we want first to be printed first, the second to be printed the second, and third to be printed at the third. But with this code, the behavior is like this. the first is printed first, but after that, it waits for 3 seconds before it printed third, and after that, second. So our code have some problems. It actually has a blocking code because of the time slip over there. So what I learned is that we need to use an async IO compatible library. So we cannot just use Boto3 with async IO. We need to use, let's say, AIO Botocore, the asynchronous version of Botocore. And internally in our company, we also develop some libraries, also created by the great teammate over there. So we have like AAPNS, it's a asynchronous Apple push notification service to send push notifications to iPhone. And we also developed something called Arsenic. It's an async WebDriver implementation for async IO. And this is, yeah, the thing with async IO is initially, like in the early age, there are a lot of libraries that doesn't support it, but now it's 2019, so you have like a lot of options and library out there that probably already supports async IO. And now, if it's a correct code, the difference is that this one is used time slip. This one you already use, let's say, IO Botocore. Now you have a proper library, and the result is like this: is prints first, then the second, and then after that it waits for 3 seconds before finishing printing the third. And we also have problems with third-party library apparently. So this is a tale of using Botocore. So once upon a time, we decided that it's time to upgrade our lock dependency in production, right? It should be like, okay, let's use the latest stuff, the sparkling newest things. But unfortunately, it doesn't behave as we want. For some reasons, like our average response time just like jumped from 200 milliseconds to 500 milliseconds. And we tried like to pinpoint what went wrong. And finally, we found out that actually Boto3, the AWS SDK that we upgraded, has some problems. So we tried to do the binary search in the version. Let's say we use version 1.6. We try to jump to 1.4. And 1.4 still work. We jump it back to 1 point something. Or, it doesn't work here. We jump it forward. So after we do those kinds of things, we found out that someone also has the same problem in the internet. Of course, it's the internet. Everyone, like, fortunately, this issue has a problem, not like certain Stack Overflow threads. And apparently, Botocore at the time, they changed their signature version. And the library needs to like pass the region name inside when you initialize the library, you need to pass the region name. Otherwise, it will try to ask the server in the US East to resolve the region name, which is latency problem. So what we learned from this thing is you need to do a performance test and upgrade your dependencies often. Because, yeah, of course, in production environment, to be safe, you should use the locked version of dependencies. But in staging, you should try upgrading your dependencies as often as possible to avoid these kinds of problem, because it's not nice. Like trying to dissecting where the problems comes from is so annoying. And you should also do some performance tests to test like the average response time, the CPU usage, the memory usage, and so on. The other things are about Python-specific improvement. So I'm just wondering how many people here is still using Python 2? Okay, there's still some people using Python 2. So yeah, just a reminder that end of life for Python 2 is January 1st, 2020. And if you are developing a web application, Python 3 is like very useful. We actually get like 30% faster improvement by migrating from Python 2 to Python 3. So this is Python, like the comparison from our server. We compare, this is in second. So before we migrate to Python 3, our 50%, like the 50% percentile is around like 0.35, 350 milliseconds. But after we migrated it to Python 3, it just drops to 250 milliseconds. And as you can see, it's actually more stable. The performance is more stable compared to Python 2. Python 2 has a lot of fluctuative average response time over there. And for the CPU usage, of course, because you can serve a request faster, the CPU usage also goes down. As you can see, this is like the CPU usage for our instance before we migrate to Python 3, and that one is after we migrated. This is 1 week's data. And this is also a best practice things that when you migrate from Python 2 to 3, try to do the best practice. For example, if you know about type hinting and if you know that data class is introduced in Python 3.7, and if you don't know about that, let me give you some brief introduction. This is what Python 3.7 code will looks like. This is very nice. I'll say you have a data class over there. The frozen true means the object that you create will be immutable, that you cannot change it. And let's say you have a class user that has a username which has a type hint over there. It's a string, and a display name which is optional, and the type is a string. And there's also a class method over there that tries to read from, let's say you pass the database object and you want to convert it into a user object. So you can do something as simple as this. You can say, like at class method, this method will accept a data that is a dictionary, and it will return a user object. So this is very nice, especially as you know, Python 2 and Python 3 has some differences, especially in handling string and the Unicode and byte stuffs. So when you have this, you actually can keep track where it goes wrong. Oh, this one should probably return bytes. This one should probably return string. And with the immutability of the data class, you can make sure that other developer don't mess with your code. Let's say this method should be only read only from the user record. You can make sure with this class that other developer will not mess and write something on your object. And we also have some infrastructure optimization. Since we are using AWS, if you are familiar with the mixed auto scaling with spot instances, so in the past we used to buy a lot of reserved instances, but after calculating the cost, it's actually not worth it. Like spot instances actually give better performance, so we decided to use mixed auto scaling with AWS. And we also learned that we need to track some unused stuff, because in our environment apparently there's like a lot of unused load balancer, and one load balancer costs you like $20 per month per load balancer. And sometimes you also have unused disk volume, so make sure to clean your infrastructure, like your AWS stuff, as often as possible. And you also need to think about the retention period about your logs or your database backups and stuff. So there are also like various improvements. We don't actually use all of this, but this is like a very specific use case, depends on your web application. For example, if you have some commonly accessed data, you probably want to cache it with Redis or CDN. Or if you have some problem with your CPU, you want to probably improve your data structure. It's actually rare to happen, but it might happen. And for example, if you're running in an environment that is low in memory, you want to use generator instead of for loops. And you can also utilize memory profiler and PDB to pinpoint your bottlenecks of your system and so on. And I know that some people might ask these questions. So why don't you go serverless, right? Serverless is like a buzzword for nowadays. Everyone are talking about serverless. But we actually tried doing serverless initially, but we found out that it's not worth the effort, especially the developer time. Because with serverless, the complexity of your infrastructure will goes up. You need to do a lot of wiring, let's say with Terraform and stuff to connect everything. And we also have problems with, like it's a bit hard to test because you need to do a lot of cryptographic stuff. You need to like handle the, like tie the OpenSSL version, but we don't know which version the AWS Lambda use. And we also have problems with the log processing and monitoring stuffs, because we totally depends on which path that we use. Since we use AWS, we have problems that everything are tied to AWS. We don't really have a lot of choices for that. And the other things is, why don't you use an X language? So this is based on someone research. They show that with Python, the median hours to solve problems is actually very low. Like Python is probably one of the easiest language in the world. So the thing that I want to say here is we need to optimize for user experience, and the cost savings we actually comes by itself. So what we achieved by end of 2017, our average response times after doing all of these is went down from 400 milliseconds to 150 milliseconds. And our AWS cost bills went down from 250 to 100,000 per year, which is 60% savings. And by the way, we are serving 4 million users in 5,000 companies in Japan. And yeah, this is the end result. After we are doing everything, it just went down. The average latency just went down over there. And yeah, does it worth the effort? If you think about it, if you really only want to optimize your stuff, I will say it's not really, because your developer time is actually more costly than that, right? The savings that we got here is probably the cost of 2 developers, but there's a but. Yes, for the sake of the better user experience, because if you can maintain your churn rate, lower churn rate, you can maintain your user to keep using your product, that is good. And with Python, you can also do a faster rate of time to market compared to other language. And yes, as you know, that improving these things is not a one-time thing. You need to do it one step by step. Let's say you need to do Python 2 to 3 first, and after that you need to finish the type hinting, and after that you need to migrate to data class. So it's a step-to-step thing. So it doesn't like happen in one day. And knowing the best practice helps a lot. That's what I can say here. Any improvement made anywhere besides the bottleneck are an illusion. So we don't really need to think about which framework that we want to use. We can use any framework that we want. Usually the framework is not your problem. Your problem is your code. So conclusion, for most web applications, the slowness of Python is negligible because the bottleneck is usually on I/O bound operations. A lot of popular websites, they prove that they can use Python, such as Instagram. But if you really have a lot of CPU bound computations, you can actually offload some of those tasks to, let's say, C or C++ with Python, or you can also delegate some of those tasks, like to say to other languages such as Golang. And yeah, self-promotion here, that we are recruiting people. So if you looking for a new job, especially if you want to have an interesting experience to work in Japan, please come to our booth. We also have a recruiting session today here at 3:30 to 3:45 after the first keynote. We already have a lot of interns around the world. We have like some Italian in the past. We also have a lot of European, Asian, Americans. And if you are interested in anime, you can visit or come talk to me directly about it. And that's it. Thank you.